Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are going to see about the chapter atoms and molecules. In this session, let us discuss about the introduction part of this chapter, especially the laws of chemical combination. The chemical laws which explains the combination of different chemical substances. In the earlier chapters, like is matter pure, we used the terms like elements and compounds, isn't it? Yes, there we have used the terms elements, compounds, mixtures, even like the classification of matter we have seen there. Based upon the composition, matter has been classified into two types. What are those two? Pure substances and impure substances. So again, pure substances are categorized into two parts. They are elements and compounds. So there we have used these terms. The pure substances containing only one kind of atoms are called elements, and the pure substances which are containing different kinds of atoms combined chemically are called compounds. We learned about the role of separation techniques in identifying the elements. Is how to identify the elements by using different separation techniques also we have seen in the chapter. The pure components obtained after separation are either elements or compounds, isn't it? So we have seen in the same chapter about the different separation techniques also. The components of a mixture are separated by using different separation techniques. So once if you separate those, the pure substance obtained from that separation technique might be either an element or a compound, isn't it? Yes, we have seen this all in the is matter pure chapter. Different kinds of classifications of matter and different mixtures and their separation techniques we have seen. So once if a mixture is separated, we get there either an element or a compound as a pure substance. So here we can use this knowledge to explain some of the observations made in previous sessions, like rusting of iron or rusting of iron rod kept outside. So what happens if we keep the iron rod outside? We know that will get rust. So how does it happen? How will be it done? We know iron on reaction with atmospheric oxygen in the presence of moisture, it will get rust. So what happens when an iron rod getting rust? So that we are going to see in this chapter. The chemical reactions like this. So Antony Lavoisier was a French nobleman. He made many important contributions to chemistry, and some call him as a father of modern chemistry too. Yes, Antony Lavoisier has given many contributions in chemistry, in chemical reactions, in studies of the elements also. He has done many experiments, many contributions too. That is why he is called as father of modern chemistry, Antony Lavoisier. Lavoisier studied combustion reactions in detail. So what is happening in the chemical combustion reactions? He done many experiments on these combustion reactions. He studied more about those. He was able to find the masses of the reactants and products accurately irrespective of their physical states. So what he did? He found the masses of the reactants. What is meant by here reactants? So the chemical substances which are participating in a chemical reaction are called as reactants. For example, just now we have told iron rod getting rust when it is kept in the atmosphere in the presence of moisture. So what is happening there? Iron metal reacting with atmospheric oxygen in the presence of moisture. So in this chemical reaction, the substances which are participating in the reaction, like iron rod, atmospheric air, that nothing but oxygen, and moisture or water vapor. These three are participating in the reaction. So these three are called as the reactants. Okay, the chemical substances which are participating in the reaction or the chemical substances which are involved in the chemical reaction to form new substances are called as the reactants. Now, the chemical substances which are formed in a reaction are called as the products. In the same reaction, what we told now, in that reaction, iron reacts with atmospheric oxygen in the presence of moisture to form rust. So finally, chemical rust is formed. That rust comes under here product. So the chemical substance which is formed in the reaction is called product, and the substance which are participating in the reaction are called reactants. So he studied about the masses of these reactants and products carefully, and he found out the masses of those substances accurately, irrespective of their physical states. Means whatever the state might be, either it is a solid or liquid or gas, he observed all the masses of those reactants and products. If you see in the same reaction again, the iron reacting with atmospheric oxygen in the presence of moisture. Here, iron is in the solid state. Its mass is calculated. And atmospheric oxygen and moisture both are in the gaseous state. Even though they are in the gaseous state, their masses are also considered as the masses of the reactants. And after that, finally, rust is formed. The mass of rust is also calculated. In this way, the masses of the reactants and products are calculated accurately, irrespective of the states, based on his observations. So he observed there the masses of the reactants are exactly being equal to the masses of the products formed after the reaction. Based upon these observations, he proposed the law of conservation of mass. So what he observed here in his observations, he found that the masses of the chemical substances which are participating in a reaction, irrespective of their state, either solids or liquids or gases, that is being exactly equal to the masses of the chemical substances formed, that is nothing but products, irrespective of their state also here also. So whatever the state might be, the total masses are being exactly equal before and after the chemical reaction. So based upon this, he proposed a law which is known as, which is very familiar as to us as law of conservation of mass. So earlier it was thought that mass of charcoal decreases on burning. Yes, before his proposals like law of conservation of mass and before his studies, what they have thought, in some chemical reactions, the masses of the substances are being decreased. In some chemical reactions, masses of the substances are being increased. That they were taught. Because, for example, if you say burning of charcoal itself, so before burning, charcoal will be having some mass. If you burn the charcoal, after burning, what will be remain? Ash will be remained. If you observe the mass of that ash, it will be obviously less than that of the charcoal. So in that way, people they have thought that mass of the chemical substances are being changed in a chemical reaction. For example, the mass of charcoal decreases on burning. It was it was a thing they have thought at the time. But Lavoisier carried out the burning of charcoal in a closed apparatus and found no change in the mass. So what he has done, he done the same burning of charcoal experiment but in a closed apparatus. So that he found finally there is no change in the mass. So what is happening practically here? Charcoal we know as it is a solid substance, so we can calculate its mass very carefully, very accurately also. But when you burn it, finally it is producing certain gases like carbon dioxide and water vapor. So those will be escaped from the content. So finally what is remaining here? Only ash, solid ash is remaining. So if we calculate the mass of only ash, we get it less than the mass of charcoal. But what we have to do actually, along with the mass of the ash, we have to calculate the mass of the gases escaped, because those also produce in the same reaction. So we have to collect those gases also. These all will come under products. Along with the ash, those gases like carbon dioxide, water vapor, and some other gases, whatever are being produced. So if you calculate the mass of these all substances, that will be exactly equal to the mass of the charcoal and the gas combined with that. So in this way, he has done several experiments, and in these all, he observed the masses of the chemical substances participating as reactants and the masses of the substances being produced as the products. So, irrespective of these states, if there are gaseous substances involved, then that reaction is done in a closed apparatus. Then there is no escape of gases. So, finally, the masses of the products and reactants are being exactly equal. So, based upon these observations, he proposed this law of conservation of mass. So Anton Lavoisier, on the basis of his experiments, he proposed the law of conservation of mass. It states that matter neither created nor destroyed during a chemical reaction. To say more simply, the mass of products is equal to the mass of the reactants in a chemical reaction. So the whatever the mass of the chemical reactants are being before the reaction, the same will be the mass of the products formed after the chemical reaction. Just they are changing from one form to another form. That's it. But there is no change in the total mass. That is a simple explanation for the law of conservation of mass. To say definitionally as matter neither be created nor be destroyed during a chemical reaction, but it changes from one form to another form. There might be change in the state also, but total mass won't be changed. Okay, this is a law of conservation of mass. So let us observe this law of conservation of mass based upon certain activity which proves this law of conservation of mass. So for this mass for this actually for this extra activity, we need some chemicals like lead nitrate, potassium iodide, some distilled water, some conical flask, two conical flasks, spring balance, some test tube, or thread, and a stand. So by using this, how can we prove this law of conservation of mass? Let us see here. First of all, we have to prepare a solution of lead nitrate by dissolving approximately 2 grams of lead nitrate in distilled water. Around 100 ml of distilled water you have to take. Into that 2 grams of lead nitrate be added so that it forms a solution of lead nitrate. See here how it is shown. In this way, lead nitrate solution will be formed. This is prepared in the conical flask. Now, in the same way, you have to prepare in another conical flask. 2 grams of potassium iodide you have to take, and this to be dissolved into 100 ml of the distilled water in another conical flask. So it forms a solution of potassium iodide. So what is done in this? So the experiment which proves the law of conservation of mass, we are trying to say, observe. In this, in one conical flask, 2 grams of potassium iodide is taken, and in that 100 ml of distilled water is poured so that it forms a solution of potassium iodide. In another test tube, 2 grams of lead nitrate is dissolved into 100 ml of distilled water so that lead nitrate solution is formed. In this way, two solutions are prepared in two conical flasks separately. Now, from this potassium iodide solution, 4 ml of potassium iodide solution is taken into a small test tube. So in this way, 4 ml of potassium iodide solution is taken into a test tube from the conical flask. Now these two we are going to use for the activity. So we have to hang this test tube containing 4 ml of potassium iodide solution in the conical flask containing lead nitrate solution. Very carefully it should be done. So the solution present in the test tube should not spill into the conical flask. In that way, care should be taken. Slowly you have to hang this test tube into this conical flask by using a thread. Now we have to close the flask with a conical flask with a cork. So now carefully we have to weigh this total equipment by using a spring balance. Okay, this total flask weight we have to measure now by using a spring balance. So now we are going to note this. So what we have done? Lead nitrate solution is taken into the conical flask and the potassium iodide solution is taken into the test tube around 4 ml. This is hanged into this lead-netted solution by using a thread, and it is closed with a rubber cork. Now we are measuring the weight of this total equipment by using a spring balance. After measuring, we have to tilt the conical flask so that the solution in the test tube and the conical flask, they will mix each other. What happens when mixed? This lead nitrate and potassium iodide, they react each other and they form a new substance. New compounds will be formed. It undergoes some double displacement reaction. They form potassium nitrate and lead iodide. Two new compounds will be formed. So that reactants mix each other and they undergo chemical reaction and they form new compounds as products. In that way, they have to be tilted. After the reaction, weigh the flask again. Weigh the flask again by using the same spring balance as shown here. So after the reaction, we have to weigh it once again, we have to measure the reading. So if you record the weights of the flask before and after the mixing, that means before and after the chemical reaction happening inside, we observe we get both as the same. There will be no change in the weight. So what is happening actually in the chemical reaction? Lead nitrate and potassium iodide, they're reacting each other and they're forming two new chemical compounds. So that we say double displacement reaction is happening inside and two new compounds are formed. But interestingly here, before the reaction and after the reaction, weight won't be changed. Mass or weight will be constant. Only chemical reaction is happening, rearrangement of molecules is happening, new substances are formed. So there is no change in the overall weight. So this proves a chemical reaction takes place and the mass remains same before and after the chemical reaction. Therefore, mass is neither be created nor be destroyed during a chemical reaction, but it might be changing from one form to another form. This is happening in a chemical reaction. So, in a chemical reaction, mass neither be created nor be destroyed. That means whatever the mass of the chemical substances we have taken before the reaction, the same mass will be remained after the chemical reaction also. But what happens in the chemical reaction? Some substances they react each other and they might be converted into new form. That means matter being converted from one form to another form. In this changing, there might be change in the state also. In the chemical reaction, initially you might have taken solids, but they might be converted to gas solids or gases or liquids after the reaction. There might be change in the state. There might be change in the compounds formation. There might be change in the colors, but there won't be change in the mass of the substances. Total mass before the reaction and after the reaction will be same always. This is illustrated as the law of conservation of mass, which was proposed by Anthony Lavoisier. Okay, got it? Next, let us see one more law, that is law of constant proportions. Joseph Proust proposed this law of constant proportions. He was a French novelist, critic, and essayist too. Okay, Proust took in his experiments for proving this law of constant proportions. So he took water from different sources and found that the weight percentage of oxygen and hydrogen was same in all samples. There was no relation between the place from where the sample came and its composition. So, from wherever you take a chemical substance, the chemical composition of the elements in it will be constant. From wherever you take and however you prepare the chemical substance, the composition ratio will be always fixed. For example, here Joseph Proust has taken water for his observations. He took water from different sources, means he took from the nature and he prepared water from the laboratory itself in different manners. So, however, if the chemical composition of water is observed, it is being constant in all the samples of water collected from different sources. The ratio of hydrogen and oxygen is being in the ratio 2 is to 1. It is being fixed. So this is the point he observed from his experiments. The chemical composition is being fixed in a substance from wherever and however it is prepared. Okay. Based on his experiments, Proust put forward the law of constant proportions, which is also known as law of definite proportions. It states that a given chemical substance always contains the same elements combined in a fixed proportions by mass. For example, just now I told water. So it has always same elements. Those are hydrogen and oxygen, and that too they are combined in the fixed proportion by mass. If you take water from any source, it will be containing two atoms of hydrogen combined with one atom of oxygen in all the samples. It is fixed. So if you say water, it is always H2O only. There is no change at all. That is called law of constant proportions or law of definite proportions. If we say in terms of mass, 2 grams of hydrogen always combines with 16 grams of oxygen to form water. This ratio won't be changed however you prepare and from wherever you collect water. It is fixed. If it is water, it contains 1 is to 8 ratio of hydrogen and oxygen respectively. It won't be changed. Okay, that is illustrated in law of constant proportions or law of definite proportions. It was proposed by Joseph Proust. This means that the relative proportion of elements in a compound is independent of the source or method of preparation. That means however you prepare the substance and from wherever you collect the sample, it's a constant or it is proportion. Relative proportion will be constant for the elements combined in that to form that compound. Okay, it is fixed. The ratio of the components present in a substance or a compound is fixed. So definitionally it is stated as a given chemical substance always contains the same elements combined in a fixed proportion by mass. This is a law of constant proportions. Let's observe an activity which proves this law of constant proportions, or the activity which was done by Proust to observe this constant proportions of the elements combined in a chemical substance. So what he done? He took two samples of copper carbonate. Its chemically formula for this copper carbonate is CuCO3. Copper carbonate is called. So it is a compound of copper, carbon, and oxygen. He took this copper carbonate two samples. He took a sample from the nature. So from the nature in the copper carbonate available in the nature, he took one sample. Another sample he prepared in the laboratory by using chemicals. So two samples he has taken means the copper carbonate is taken from two different sources. One from the nature and the other one is prepared in the laboratory by Proust. Now he took these two samples and he started decomposing them, means he started heating them at a strong temperatures. Then what happens, this copper carbonate decomposed chemically, it will be decomposed and then it forms copper, carbon and oxygen in the two samples. So when calcium carbonate is decomposed, it forms two different elements in that. From the two samples he observed the percentages of carbon, copper and oxygen separately. He noted the percentage of the samples from these two samples after decomposing. So this is happen in the reaction when it is decomposed. When calcium carbonate or sorry copper carbonate is heated strongly, this copper carbonate decomposes to form copper oxide and carbon dioxide. We know any carbonate of metal on strong heating, it forms respective metal oxide and carbon dioxide gas. Here this copper carbonate also on strong heating decomposes to form copper oxide and carbon dioxide. Now after the reaction, after decomposition, He observed chemical percentages of this copper, carbon, and oxygen in the two samples separately. The results obtained are tabulated by him. So he observed then the percentage masses of the copper, carbon, and oxygen, two different samples, or the samples separated collected from the two different sources. Interestingly, the percentages of these three elements are being same in both the samples. Even though they are collected from two different sources, their compositions are being same. So we observe that there is no difference in the percentage of copper, carbon, and even oxygen in two samples. So this proves the law of constant proportions. What does it mean? From wherever you collect the samples of a chemical substance or however you prepare a chemical substance, the composition of the elements present in that compound is fixed by mass. It won't be changed. This is a law of constant proportions. Okay, these are two laws of chemical combinations, we can say. Law of conservation of mass, which proves that there is no change in the mass of the chemical substances participating in a chemical reaction. The mass of the reactants will be equal to mass of the products formed in that reaction. Okay, that is law of conservation of mass. Mass neither be created nor be destroyed. And second law, law of constant proportions. The chemical composition of a substance is always fixed. The chemical composition of the elements combined in a compound is fixed from wherever you collect the samples and however you prepare that chemical compound. This is law of constant proportions. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on the recorded videos and visit our website aimstoday.in. Thank you.